In this tutorial, we would like to give you a general overview of hydrophilic liquid interaction chromatography, also known as HILIC, under consideration of the corresponding best-selling Shodex columns, the DeAza NH2P and Hillockpack VG series. The main applications in this mode are the separation of small polar molecules as well as saccharides in the fields of pharmaceutical industry, environmental analysis, food safety and life science. If you need more detailed information about the HILIC mode as well as about applications, please take a look at our technical notebook number 2 after this tutorial. HILIC is used to achieve a separation between polar analytes by using a combination of polar stationary phases and polar mobile phases. For example, aqueous buffer, acetonitrile mixtures. The stationary phases used for HILIC applications can be modified by different functional groups. For instance, amino, diol and zwitterionic moieties. But also pure unmodified silica particles with 3 silanal groups can be used. When we take a look at the amino functionality, the retention of non-polar analytes decreases, whereas the retention of polar analytes increases. This is caused by the increasing polarity of the stationary phase by amino functionalization. Shodex's focus lies on manufacturing HPLC columns which consist of pure polymer-based stationary phases instead of silica-based ones. The most important reason is that polymer-based particles are chemically more resistant and offer therefore a broader application range. In the case of HPLC columns, there are several improved methods to modify silica particles with functional groups, for example C18. Nevertheless, not all free silanal groups can be occupied by these methods, not even after end-capping procedures. Therefore, still high silanal contents are present, which leads to several drawbacks, especially under basic conditions and when basic compounds have to be analyzed. Our best-selling columns for HILIC chromatography is the DeAza NH2P series. The base material of these series consists of pure polyvinyl alcohol particles which are modified with polar polyamines. Therefore, this type of column can be used in an extended pH range from 2 to 13 compared to standard silica-based HILIC columns. Due to the highly polar stationary phase, this column is suitable for the separation of polar compounds. In addition, a gradient separation is also possible. Under consideration of the lower bleeding activity, this column is suitable for particle-sensitive detection methods like MS, light scattering and charged aerosol detection. Furthermore, this base material ensures longer lifetime compared to the silica-based counterparts. We offer this type in different column dimensions, ranging from semi-prep/analytical to semi-micro scale. The latter is commonly used for LC-MS applications. Furthermore, it has to be considered that this stationary phase has a quite big pore size of 100 angstrom, which makes it also suitable for the separation and analysis of oligosaccharides. You can find more detailed information in our catalogue and on our website. To emphasize the increased stability and high tolerance to time degradation of our polymer-based HILIC column, a comparison between the DeAza NH2P-54E and a silica-based amino column was accomplished. Thereby, samples containing common sugars like fructose, glucose, sucrose and maltose were continuously injected over time in both cases. A significant shift for the elution volumes in the case of the silica-based amino column was already achieved after 50 hours. After 120 hours of use, the peaks are overlapping. Thereby, no quantitative determination of the tested sugars is possible anymore, and the column has to be exchanged by a new one. In the case of our column NH2P-54E, even after 180 hours, the elution volume stayed constant and the peak shapes as well, which is clearly showing the high stability against sugar samples. One of the most important tasks in sugar detection is to decrease the bleeding activity of HILIC columns to achieve stable baselines in the chromatogram when particle-sensitive detection methods like ELSD are applied. To visualize the impact of bleeding, a silica-based amide, silica-based amino, and our polymer-based NH2P-50 4E column on the signal-to-noise ratio, as well as on the drift of the baseline, fructose/glucose samples were injected in each case and detected by a charged aerosol detector. As our polymer-based column is more resistant against bleeding, high signal-to-noise ratios and a stable baseline can be obtained. In contrast, the used silica-based columns generate significantly higher noise as well as drifts in the baseline. The NH2P series can be used for the separation of a variety of different saccharides which are ingredients in food and beverages. On the left side, you can see a chromatogram showing all saccharides in fructo-oligosaccharide syrup. Thereby, a nice baseline separation could be achieved between all sugars. In the middle, an example is shown which emphasizes the successful separation of oligogalacturonic acids, i.e. oligosaccharides, based on the quite large pore size of 100 angstrom. The example on the right shows the separation of sweeteners like stevioside and ribordioside A, which are commonly used in soft drinks. Another alternative for HILIC chromatography is our column Hillockpack VG50 series. Compared to the NH2P series, the Hillockpack VG50 series is modified by tertiary amino groups instead of primary amines. Thereby, the rest R is a hydrophilic group. The base material is the same like in the case of the NH2P series, namely polyvinyl alcohol. The most important reason why Shodex has developed this column is that based on the functional group modification, a higher recovery of aldoses is possible, compared to stationary phases with primary amino groups, as adsorption of aldoses is hindered. In addition, due to the polymeric material, the column shows excellent chemical stability and low bleeding. Therefore, this column series is also suitable for particle-sensitive detection methods like charged aerosol detection, light scattering, and mass spectrometry. In this scheme, you can see in a detailed overview how the modification towards a tertiary amine is increasing the recovery of aldoses. In the case of the NH2P series, primary amines conform with the opened ring form of aldoses, which contain aldehyde groups, Schiff bases, also called imines. This fact causes an adsorption and also a stronger retention of aldoses in the case of columns bearing primary amino groups. In the case of the Hillockpack VG50 series, the primary amine is changed to tertiary amines, which do not undergo this type of reaction. Therefore, especially when aldoses have to be determined in low concentrations, the Hillockpack VG series should be preferred. On this slide, you can see a comparison between three different columns, namely our polymer-based Hillockpack VG50 4D and two different silica-based amino columns with primary amines. Thereby, samples containing fructose, mannose, glucose, and sucrose are analyzed. In the case of Hillockpack VG50 4D, you can see a nice separation of all four sugars as well as high peak intensities, which indicates the high recovery rates of mannose. In both silica-based amino cases, in general, the sugars are retained much longer on the column, even if the flow was 2.5-fold increased. In addition, mannose and glucose showed significant lower peak intensity and an increased peak broadening, which is caused by the adsorption of reducing sugars by the primary amine functionality. On the right side in the diagram, you can see that the recovery rate of mannose in the case of the Hillockpack VG50 is almost quantitative, whereas in the case of the amino column 1, 40%, and for the amino column 2, below 20%. Therefore, it was clearly shown that the Hillockpack VG50 series is suitable and should be favoured for the analysis of aldoses like mannose, especially when you have to determine them in low concentrations. If you need further info material, please register on our new website www.shodex.de. There you can find PDF files for download, i.e. our column and detector catalogues, technical notebooks, and you have access to our application data bank. In the case you need support, please contact us via info@shodex.de. For quotes or purchase orders, please send us an email via order@shodex.de. Moreover, we offer further tutorials considering reversed phase, ligand exchange, ion and size exclusion chromatography. Thank you very much for your kind attention.